So, our first presenter this morning is Nick Brajkovich, and he's doing an architectural science degree, and his presentation is on AR and VR experience of the Legacy Living Lab. So, Nick.
Well, thank you. All right, good morning everyone. My name is Nicholas Brajkovich, and for the past 10 weeks I've been involved in the virtual reality experience of the Legacy Living Lab. And my background is being a student of architecture, and this project interested me because of its ties into virtual reality and spatial visualization, but more specifically how virtual reality experiences can be developed beyond a standard fly-through to be more dynamic, interactive, but most importantly memorable. L3 is a practice-led research project based on the circular economy framework and sustainability principles of reduce, reuse and recycle. This project aims to create a tangible asset which proves the feasibility of circular economy buildings. Designed as a multi-purpose interactive building, it will function as a research and prototyping space whilst also facilitating practical partnerships between academia and industry. Furthermore, L3 is a modular building with infinite future life cycles, the first of which will feature at the East Village Nutford's site, a Development WA and Smart Cities project from early 2020. The building will stay at the East Village site for 2 years before being moved for its second life cycle. L3 aims to educate and test the construction industry's current building methods. Furthermore, the building components have been recycled, upcycled and/or reappropriated wherever possible to promote circular economy. The building and virtual reality experience will showcase Australia's most innovative materials and technology in the field of high-quality green buildings. Several sensors have been installed in aims of monitoring energy and resource consumption with integrated smart home devices. This enables L3 to become a case study for innovative materials and technology that have been designed into the building. Another primary objective of L3 is to prove that there can be a significant reduction of waste in the building industry without sacrificing on quality of spatial experience. Virtual reality is a crucial visualization tool in showing the full spectrum of design work that has gone into L3, and was another way in which L3 could set new standards in the building industry. This project sets out to achieve a cinematic and interactive virtual environment beyond the standard fly-through experience, and is envisioned to be developed further in the future to be at the forefront of virtual reality and architectural innovations. Circular economy dictates that for things to be adaptable and reusable, they must be able to be dismantled. The first level of disassembly is the building itself, which you can see over here. L3 is able to be broken down into 8 volumetric modules in order for the building to be relocated to its next location with less than 1% of the mass going to landfill. Virtual reality enables visitors the opportunity to explore firsthand how L3 is modular and can be pieced together or taken apart in modules. The second level of disassembly relates to the walls of the building. These are designed in non-continuous sections so that they may be removed without the need for cutting or for cranes and other heavy lifting equipment. By having wall finishes and roof panels that are removable and resilient, the constant evolution of the building can happen without creating waste. Virtual reality can enable visitors to see through the wall sections and help them understand the importance of the design approach without actually taking the building apart in reality. Apart from showing design elements, the virtual reality model also enables a virtual passport indicating where materials and products have been in their past life, so users can understand material provenance and appreciate the value in circular economy, showing the repurposed materials' age, past uses, but most importantly how they've been reappropriated for their current life cycle. So the virtual reality experience that I develop is driven by the objectives to allow visitors to look behind the walls of the building, giving them the opportunity to experience details that have been hidden by wall linings, to allow a visitor to interact with the virtual L3 twin and learn about components that have been reused or recycled as part of the building's circular economy approach, to gain a realistic spatial experience without actually being there, and to experience how the building is modular, witnessing virtually how the building pieces together module by module. What can be seen on the screen is a breakdown of the software used to develop this virtual reality experience. So the first one, Revit, by Autodesk, is a BIM platform commonly used by architects, engineers and designers, and it was used in this project because the 3D model received was initially developed in Revit. From there, 3ds Max is a tool by Autodesk which I used to enhance how the 3D geometry from Revit would import and perform in Unity. Unity is a real-time game engine that allows one to develop almost anything they like with 3D geometry. Unity facilitated the development of a virtual reality experience viewable in the provided HTC Vive Pro kit. Photoshop is a graphic design software by Adobe. It was used for custom images throughout the virtual reality model. And the final product is a result of 10 weeks of development. And it includes a trial user test and feedback session which was utilised to enhance the virtual model beyond its first draft. So while the virtual environment can be explored openly, there is a designed sequential experience for the virtual reality showcase, which I'll talk you through right now. So upon wearing the HTC Vive Pro kit and launching the virtual reality experience, the visitor will find themselves outside with L3 in view. A voiceover will greet the visitor and instruct them on user controls and to make their way to the welcoming panel that's in view. On this panel, the visitor can interact for the first time with the virtual environment, finding out more about the project, the people involved, and even triggering an animation of how L3 pieces together modularly. At the completion of this animation, the accompanying voiceover instructs the visitor to either explore around L3 outside or to continue on to the front door along the pathway in view where they can continue their experience of learning about how the building embodies circular economy. Oh my God, that just freaked out. Slide 10. Thank you. Okay. So as the visitor makes their way teleporting along the path to the front door, they can interact and discover for the first time information regarding circular economy and how it's been designed into L3. Furthermore, a revision panel, which you can see here, can be triggered if the visitor needs any reminder of what to do in the virtual experience or requires assistance on user controls. The visitor now enters inside, and in view are multiple interactive points which reveal information about the lab and how it embodies the circular economy framework. At this stage, the visitor is free to teleport around and discover for themselves throughout the ground floor the various innovations designed into L3. When ready, the visitor can then use teleport points to guide themselves upstairs, where further interactive components reveal circular economy innovations. Like downstairs, the visitor can teleport wherever they please. There is no linear order to the interactive buttons of the virtual environment. The visitor will eventually find themselves outside on L3's balcony. There are a few interactive buttons on the balcony returning the visitor to the concept of circular economy, but one button stands out, and this triggers a concluding voiceover of the virtual experience. The visitor will interact with this button and is thanked by the voiceover for experiencing L3 in virtual reality, and the voiceover will continue to ask the visitor to remove their headset, and the virtual reality experience of the Legacy Living Lab will conclude. There we go. Whilst most of the comments made in the trial testing feedback were amended in this project's final outcome, some comments remained unresolved due to time restraints and represents ways forward for the virtual reality experience of L3. One of the desired outcomes of this project was to be able to see behind the walls of L3. This was achieved to a certain degree, manipulating photographs of the real-life structure into the virtual model. Through access to or having more time to create a detailed Revit model, the quality of the virtual representation of behind-the-wall details could have been drastically improved. If components like plumbing, HVAC and building structure were all modelled in 3D geometry, the possibilities for showcasing, animating or interacting with these in Unity could have been explored for this project beyond a toggle on or off 2D image. This virtual reality experience does educate a user about L3 and circular economy through an immersive experience. The educational element of the virtual L3 twin could be further improved through increased user interaction. This build of the virtual experience requires interaction from the user to toggle on and off informative panels. Creating a game within the experience could improve this sense of interaction and further a visitor's retention of information learnt. For example, to educate the user about how L3 is modular, an opportunity to piece together L3 in virtual reality could be a great opportunity for interactive learning. This particular scenario could involve the user clicking a button which makes the building fall apart into its modules, and that the user can then click, drag and piece together the building whilst learning about how it is a modular design. So developing a realistic terrain setting would increase realism and improve a sense of context and scale. With L3 currently on a relatively undeveloped construction site, the forest setting that you'll see in the virtual reality demonstration was opted for just to polish the looks of the virtual reality model. Materiality and lighting can be optimised. With more time, material look and lighting atmosphere in L3 could be improved in terms of realism. Looking closely at some materials, the tiled effect of box mapping is evident. The next developer could take this project further by creating much higher quality material textures that do not create any seams when mapped across the building surfaces in virtual reality. On a final note, as stated, lighting can be improved. So currently the lighting environment does require a large amount of processing power. So light baking, which is a Unity tool, has been attempted through, but frame rates in the virtual reality headset still drop slightly. So there's an opportunity to really smooth the virtual reality experience in the future. To conclude, I would like to give thanks to Timothy O'Grady for allowing me to be involved in this project prior to any involvement with HIVE or the official project scope. Thank you for believing and trusting in me to be involved with the VR development of L3. All the site visits prior to starting the project really gave me a great insight into L3 and allowed me to understand it much better than off a set of drawings. I would like to thank all my supervisors, Dr. Rebecca Lang, Timothy O'Grady, and Dr. Christine Eon for their support in this project. You have all had input into this and it has shaped it into what it is today. Thank you for being supportive throughout the project timeline and making me feel like a welcomed team member. To Curtin HIVE and its staff, as well as Curtin University, CIC and CUSP, thank you for this opportunity to learn, create and experience something truly unique. This project has allowed me to explore the possibilities of VR applications in the built environment, and everyone's support throughout this project has been greatly appreciated. So thank you.